Claude Code did not win attention because developers needed another chat window. It mattered because the terminal is where a software task becomes real. A ticket is not a prompt. It is a failing test, an old decision, a dependency, a production constraint, and a teammate waiting for an answer. The interesting question is no longer whether a model can write a function. It is whether it can understand enough of the surrounding system to make a useful change. That is the story behind an agentic coding tool. You describe an outcome, the tool reads, it searches, it forms a plan, it makes a small change. Then it checks the result. The interface looks simple, one command line. The work behind it is not simple at all. Autocomplete made coding faster at the point of typing, but most engineering time is not typing. It is reconstructing context. A bug report sends you through an error, then a caller, then a configuration file, then an old test that explains the behavior nobody documented. A good agent starts there. It does not treat the first plausible file as the whole problem. It collects evidence. It looks at source, tests, history, and documentation. It tells you what it found before it proposes a mutation. Context before code is not a slogan. It is the difference between a patch that looks right and a patch that survives contact with the repository. That changes the basic loop. A strong request is not, make this work. It is, trace this failure, explain the likely cause, propose the smallest safe change, and run the focused tests. The plan is visible. Each step has a reason. Read these files. Search this symbol. Inspect this test. Change this boundary. Verify this behavior. The human can interrupt before a write, or ask the agent to challenge its own assumption. This is why a command line can become more than a command line. It becomes a shared workspace for reasoning, tools, and review. Tools are what turn a model response into an engineering workflow. A search result is evidence. A file read is evidence. A test failure is evidence. The agent should not bury that evidence under a wall of terminal noise. It should show the useful result, connect it to the next decision, and keep the change budget small. One focused diff is easier to understand than a spectacular rewrite.
A passing test is necessary, but it is not the entire verdict. The edge case still matters. The review still matters. The audit trail still matters. The best moment to ask a human for attention is not after everything changed. It is when the consequence becomes irreversible.
That leads to the uncomfortable part of the story. Agency needs guardrails. Anthropic has written about permission fatigue, noting that users approved roughly 93% of prompts in its telemetry. A permission dialogue is not meaningful supervision if it becomes muscle memory. The better question is not, did the user click allow? It is, what was the agent actually able to reach? Bound the directories. Separate credentials. Keep secrets out of output. Put network and production access behind explicit controls. Ask for a review where a change has real blast radius. An agent can be fast and still be wrong. Tests, code review, continuous integration, and production signals are not obstacles to autonomy. They are the system that makes autonomy usable. So what does the new interface mean for you? Start with a real problem that you can verify. Choose a small task with a test, a clear owner, and a reversible diff. Ask the agent to inspect before it edits. Read the plan. Read the diff. Run the tests. Then expand the scope only when the workflow earns your trust. The future is not a machine replacing judgment with a single command. It is a tighter loop between intent, investigation, tools, verification, and human responsibility. The terminal is becoming a teammate. Your advantage is knowing what to ask it to understand, and knowing when to stop and look closely. Start with the terminal itself. For years, it was a place where developers translated decisions into commands. You wrote the implementation in an editor, but the terminal was where the repository told you the truth. A build passed or failed, a migration succeeded or destroyed a local database. A test exposed the part of the system you had forgotten. That is why a coding agent in the terminal feels different from a chatbot beside the editor. It can work where the project already lives. It can see the directory structure, the package scripts, the test runner, the version control history, and the small conventions that never make it into a specification. None of that makes it automatically correct, but it gives the model something better than a blank text box. It gives it a situation. The shift is that the interaction became a loop. You state a goal, the agent investigates. It comes back with uncertainty instead of pretending certainty. It decides what evidence would reduce that uncertainty. Then it acts in a constrained environment. If a test fails, that result is not an embarrassment to hide. It is the next piece of evidence. This is much closer to how experienced engineers work. They do not begin with the largest possible patch. They begin by finding the narrowest question that can change the plan. Imagine a simple bug report. Customers cannot save a profile after updating an email address. An autocomplete tool may help you write a conditional. An agentic workflow begins earlier. Which endpoint owns the request? What validation runs before persistence? Is the failure in the browser, the API, the database transaction, or an integration with a downstream service? Which test already describes the expected behavior? Has this happened before? The fastest patch is sometimes to change a validation rule. The safest patch may be to discover that the contract was wrong, update the test, and preserve the existing rule. A coding agent earns trust when it makes this path visible instead of skipping straight to the first edit. That visibility matters because repositories are full of local knowledge. One team uses a small helper to create database records. Another encodes security boundaries in middleware names. A test may look redundant until you see the production incident that added it. An agent can search quickly, but speed is not understanding. The right workflow makes evidence legible to the person responsible for the outcome. Show the file, show the call path, show the failing assertion. Explain why a proposed change is smaller than the alternatives. If the tool cannot explain its choice, the human should not be expected to trust it. The useful unit of work is not a spectacular answer. It is a reviewable decision. Before an agent changes code, ask it to write a compact plan. 4 or 5 steps are enough. Inspect the relevant files. Confirm the existing behavior with a focused test. Make the smallest patch. Run the tests that cover the behavior. Summarize the diff and any remaining uncertainty. A visible plan lets you correct the problem before the agent spends time solving the wrong one. It also makes collaboration easier. A teammate can read the plan, point out a missing service, and redirect the work without unraveling a long chain of edits. Plans are a natural place to separate what should be automatic from what should require approval. Reading code is usually low risk. Searching a local directory is low risk. Editing a test fixture may be reversible. Updating a production configuration, rotating a secret, deleting data, or sending a migration deserves a different boundary. The point is not to make the agent ask permission for every harmless command. That creates fatigue. The point is to make permissions meaningful. Put a gate at the action with real consequence. Then describe the consequence in plain language. The tool loop has a rhythm. First, observe. Read a file, inspect an error, or search for a symbol. Second, decide. State the inference that connects the observation to the next move. Third, act. Run the narrowest command or apply the smallest diff that can test the inference. Then observe again. The rhythm is simple, but it prevents a common failure mode. The agent makes many edits before it has learned whether the first assumption was right. In a large code base, momentum can be dangerous. A fast agent can travel a long distance in the wrong direction. Small checkpoints make the route recoverable. Consider test output. A green check mark looks definitive, but it only proves what the test actually covered. If the test runs against a mock, it may miss a database constraint. If it checks a happy path, it may miss a permission edge case. If the change affects a public API, a snapshot may need an update for a reason you should understand. The agent can help enumerate these gaps. Ask it, What assumption does this test not exercise? What user role could behave differently? What error path remains untested? This question turns the agent from a patch generator into a critic of its own work. Dynamic workflows matter because real work is often not one tool call. A feature may involve a front end, an API, a schema, a background job, a dashboard, and a deployment script. The useful behavior is not to touch all of them at once. It is to build confidence across them in an order that preserves feedback. Map the path. Identify the owner of each boundary. Test the narrowest integration. Stop before a wide change if the evidence does not support it. Use the agent to reduce coordination cost without removing engineering judgment. Security becomes more important as the tool becomes more capable. A coding agent may see environment files, deployment commands, private repositories, or production identifiers. That means the project needs containment. Give the tool the minimum directories it needs. Use short-lived credentials. Keep secrets out of prompts and terminal output. Separate a sandbox from a system that can reach production. Restrict network access if the task does not need it. Record what the agent changed and which commands it ran. These are the same habits strong engineering teams use for people and automation. A flood of prompts teaches people to click through prompts. That is not safety. It is theater. Better safety is architectural. A sandbox can prevent an untrusted process from reaching a credential. An egress rule can prevent it from calling an arbitrary endpoint. A scoped token can limit the damage of an accident. A protected branch can require review before a change lands. These controls do not require the model to be perfect. They assume it is imperfect. The goal is not blind autonomy. The goal is useful autonomy with a limited blast radius. The practical starting point is deliberately boring. Pick a task you can verify in less than an hour. Ask the agent to explain a failing test. Ask it to map a request path. Ask it to propose a patch without applying it. Compare its plan with your own. Then allow it to make one small change and run one focus test. Read the diff. If it did well, increase scope gradually. If it missed context, improve the prompt or the project instructions. Good agent use is a learned collaboration pattern. It is not a switch you flip on Monday morning. Project instructions are a powerful part of that pattern. Tell the agent how to run tests where generated files live, what should never be edited by hand, how secrets are loaded, and which changes need approval. Record the conventions that senior engineers usually carry in their heads. The agent benefits, but so do new teammates. A clear repository is easier for a human to work in and easier for an agent to work in. If the tool cannot find the right command or understand the architecture, perhaps the project is missing documentation that people need too. There will be failures. The agent will misunderstand a requirement. It will choose a plausible but wrong file. It will run a broad command when a narrow one would have been better. Treat those failures as workflow feedback. Tighten the boundary. Add a test. Clarify a project instruction. Make the review step more explicit. Do not respond by asking the system to sound more confident. Confidence is not the missing ingredient. Evidence is. The best teams will make evidence, constraints, and verification part of the normal loop. Claude Code represents a change from asking a model for code to collaborating with a system that can inspect, plan, use tools, and verify work. It can compress the time between a question and a tested experiment. It can make unfamiliar code bases less intimidating. It can help a small team attempt work that once required a long handoff. But the shift only works when the human remains responsible for intent and judgment. Tell the agent the outcome. Give it enough context to investigate. Bound what it can do. Read what it changed. Verify the result. Then let the next task teach you where the collaboration should improve.